Everyone, this is Jansh, and today we'll be solving a problem that is three pulses. And I will walk you through the code, the block diagram, and how the code is working, and all things, and the concepts you would have never done before. So just grab your laptop, and the problem is already being dropped in the description, so you can take it from there and open it and code along with me as we go. So let's get started. So the problem says is design a circuit that monitors two serial inputs, that's Xi and Yi. Count the Yi pulses between consecutive Xi pulses. When Xi fires, assert PO if and only if exactly three Yi pulses have been occurred. So you have to assert the PO signal only and only if Xi is there, and second condition is three Yi pulses have been occurred. Then you have to assert PO signal. Okay. So we have Xi signal, Y signal, and PO signal, that is the output. Block diagram is on the left we have clock reset Xi and Y, and on the right we have PO, that is the output. Internally we have made or created one counter that will keep track of the count of Y. Like it will keep track of the number of Y pulses have already been occurred. Now PO condition has already told Xi should be there and count should be equal 3. Then only we have to assert the PO. Next is the rules. Each variable increments the counter, right? We have to increment the counter whenever y occurs. Then we have when xi fires, check count and reset the counter to 0 because xi will act as a window. Whenever xi occurs, we have to reset the counter to 0. PO fires only if count equal 3 at the moment xi goes higher. This is the same condition that I already told. PO will only be fired when xi is there and count is equal 3. This is the trickiest part, that is the simultaneous xi and y. We will cover this later in this video only. Then is asynchronous reset. We are using asynchronous reset because whenever we toggle the reset, all the things will be reset to 0 and all the progress will be lost. Okay. Now the question is, you will ask me why we need a 3-bit counter rather than a 2-bit counter, because you will say we have to only count till 3. But the problem is whenever our count goes beyond 4, like goes beyond 3, it will wrap back again to 0. We don't want this condition to occur, because if we are having, like if the y pulses are 7 or 5, for example, 1 2 3 4 5 6 and 7, we are having 7 pulses, so after 3 it will again wrap back to 0. But we don't want this, because this will, this should be hold at 4, because these pulses are counted. So like if xi occurs after this, we have to assert PO, because already 3% pulses have been done. And if we will not uh, uh, take off 3 bits, then it will not be able to count beyond 3. We want the count beyond 3 because we have to hold at 4. If the count goes beyond 3, we will hold at 4. Like we will say ki already 3 pulses have been occurred. So if the xi occurs in future, we will directly assert the PO signal. So this is the problem if we are having only 2 bits of counter. Now let's see the two always style. And this is the industry level style we are coding. We will be using two blocks, that is the combination block and the sequential block. In the combination block, what we'll do is we'll just calculate the value. We will not update the value. And in the sequential block, we will update the value on the negative edge of the clock or at the positive edge of the clock. So in this, we are using the positive edge of clock. So we'll update the value on the positive edge of the clock. And in the combination block, we will just calculate the value. It is like a whiteboard. So on whiteboard, we are calculating something, but we are only updating when the rising edge occurs. Okay, so that's why we are using sequential block. Now next is the this flow diagram. If you will understand this logic or this flow, you will be able to code whole problem in under 10 minutes. Okay, so let's understand this next state logic. So priority is if priority is xi overrides yi. What this means is if the xi occurs, we have to just reset the counter to zero. If so, let's go let's understand this logic. First is if only xi is high. If only xi is high, we will reset the counter, and if yi is also high, we will wrap back count next to 1 and else 0. So what we are doing is if there is if only xi is high, we will just reset the counter. We will not do nothing else. Okay, we will not do anything else. What if yi is also there on the same edge? So we have to count this pulse for the next window. So instead of going to count next to 0, we will make count next equal to 1 and else it will be 0. Next condition is if yi is high and xi is low. So we will have to keep track of these yi pulses. So what we will do is we'll simply uh, increase the count by 1 whenever the yi pulse occur, and it should be total count should be less than 4. Okay, we will increase the count by 1 whenever yi occurs when xi is low, else hold the count at 4. If it goes beyond 3, we will hold the count at 4. Okay, and if neither xi nor y is high, what we will simply do is we will simply hold the current value. We will not increase the count. Okay. Next, we are moving towards the code. So this is the trickiest case which we have to solve, that both xi and yi occurs in the same cycle. Okay. If xi is also there and yi is also there on the same cycle, we have to how we'll solve this case. So we'll code like this. If xi is there and if y is also there, we will wrap count next to 1, not to 0. Okay. This is the important point. And else we'll simply wrap count next to 0 because y is not there and xi is there. So whenever xi occurs, we have to reset the counter. Okay. Next is port interface that I've already told: clock, xi, PO, reset, Y, and count Q and count next. Q is used for the sequential logic, and next is used for the combinational logic. So these are the inputs: clock, reset, xi, Y, PO, and this is the output. Sorry, PO is the output. Then we have two counters, that is count Q and count next. Both are of 3 bits, as I have already told why they should be of 3 bits. And in the end, what we'll do is we'll simply assert PO when we will assert PO when xi is high and count is equal 3. Now we'll code the combination logic. This is the brain of the problem. So how we'll code this? Always at the star. What this means? Like if any of the variable changes, it will directly go into this block and it will calculate that value, what the variable is changing. Okay, so if xi is there and is y is also there, what we will do is we will simply wrap back to 1, and if y is not there, we will simply wrap back to 0. This is the first uh, condition logic that we have already seen now. In this we have coded already. Now the second is else if block. If only y is there and no xi. If only y is there, we will simply increase the count by 1, and the total count should be less than 4. Okay, 3D less than 4, and we will simply increase the count. Else, if the count goes beyond 3, what we'll do is we'll simply uh, hold the count. Count x will be equal to count q. We will not increase the count if it goes beyond 3. And the third last condition is when neither xi is high nor yi is high. What we'll do is we'll simply hold the count. Next is the sequential logic. So in sequential logic, what we have to do is we have to simply update that value that we have already calculated in the combination logic. So we will simply add the pausage of clock or at the pausage of reset, we will simply, what we'll do is we will use non-blocking assignment. We will simply equal count q non-blocking assignment count next. Okay. And if reset it there, what we will do is we will simply make count to 0. Yeah, so this is the whole code. And this I already told. We will, in the last, what we will do is we'll simply assert PO when xi is high and count is equal 3. This you can read from the description, this path, like, and all scenarios, edge cases. Let's go through the edge cases. Saturation at 4. Yeah, we have already coded this. So our counter will hold the value if it goes beyond 3. This also we have done, like if both xi and yi pulses occur simultaneously and back to back xi, like first xi resets counter to 0, second xi sees you, PO silent. So back to back xi means like if xi is occurring again and again, we have to simply reset the counter. Xi after reset, counter is 0, like after reset, counter will be 0, reset mid count, asynchronous reset appears, asynchronous reset clears counter immediately, like all via progress is lost start from 0. So if we will toggle the count, like the reset in the middle of the cycle, it will simply reset all the things, it will simply reset the counter and all progress will be lost. These common mistakes and learning objectives you can go through from the PDF. So yeah, this was all from my side. You can go through this PDF and you can code. Obviously, I hope you will be able to understand this problem. So yeah, I will see you in the next video. Till then, keep hustling. Bye.